What we ended up finding out after looking at very, very large samples of galaxies is that galaxies seem to be missing mass. We're actually seeing about maybe an order of magnitude less at every single mass, which is interesting. What this implies is that there exists some reservoir of gas that surrounds the galaxy, what we call the circumgalactic medium. And therefore, the physical processes that govern it must be fundamental to how galaxies evolve over time. One of the things that we found out ever since was that the galactic ecosystem appears to be similar, or at least analogous, to the water cycle on Earth. Analogously, for galaxies, you have what's called the baryon cycle, where in the same way we have the interstellar medium here that's driving these galactic outflows that at some point then mix in and recycle with this gas that's coming from what we call the intergalactic medium that then fuels the next cycle of star formation. It turns out that the CGM is actually very diffuse, so we have to rely on these chance alignments between background sources that are actually going to illuminate the gas. In other words, the CGM is so diffuse that it doesn't really emit photons very readily, so you have to use some other object to illuminate the gas. In practice, though, this is actually really hard to do. And the reason is because, again, you have this very bright background source that's right next to this very faint foreground source. The reason that it's so difficult to just remove this bright object from it is because what we're really looking at is a three-dimensional object, so it's not trivial to remove it. I spent a lot of time developing a technique to actually do this, and I'm showing on the right-hand side that, yes, we can actually recover galaxies that are this close in. For those that are not in the field, the big takeaway from this plot is that there were 8 galaxies here before. Now we have 54. So the survey actually works.